Hello everyone. Today we're looking at evaluating complex numbers. This is the last skill, topic, idea before we start reviewing for Monday's test. Reminder, Thursday and Friday this week will be review. So for f of x equals x squared plus 5, evaluate for f of 2i. We're going to do the exact same thing we would do if instead of 2i, we had a number or a variable. Because really, we still have a number, it's just a complex number. So f of 2i is equal to 2i squared plus 5. Evaluate that 2i, and we get f of 2i is equal to 4i squared plus 5. We should know by now that I squared is the same as minus 1. So this is really the same as negative 4 plus 5. Negative 4 plus 5, well, that's going to be equal to 1. So in this case, evaluating for f of 2i led to us having a real number. Sometimes we'll have real numbers, sometimes we'll have complex numbers. On to the next one. So, for f of x is equal to 2x squared minus 3x plus 5, evaluate for 1 plus 2i. So same thing as before, we're just going to plug in our 1 plus 2i into all of our x's. So this becomes 2 times 1 plus 2i squared minus 3, 1 plus 2i plus 5. This here, we're going to have to FOIL that out, or use binomial expansion, which would give us the 2 out front, 1 plus 4i plus 4i squared minus that 3 times the 1 plus 2i plus that 5. Here, we have some like terms we can simplify. Specifically, this 4i squared is the same as negative 4. That is to say that we'll have 1 minus 4 plus 4i. So, still keeping that 2, because we're going to use it later. Get that minus 3 plus 4i minus, let's distribute that 3, so minus that 3 minus 6i plus 5. Let's distribute our first terms here. So we have minus 6 plus 8i minus 3 minus 6i plus 5. So now we have a combination of real terms and imaginary terms. Let's combine our like terms before we solve them. So minus 6 minus 3 plus 5, and then plus 8i minus 6i. Now folks, a lot of these steps here, you don't have to show them all necessarily, but you should definitely show plugging in values and evaluating values. But this little step here where you're resorting all the values, you don't have to show that if you don't want to. I'm just showing it to help us organize our data. So minus 6 minus 3 is minus 9. Minus 9 plus 5, minus 4. Plus 8i minus 6i plus 2i. So 1 plus 2i evaluates to negative 4 plus 2i. This for us is an imaginary complex number when we evaluate it. Moving right along. Number 3. For f of x of 1/2 x squared plus x minus 10, evaluate for 2 minus 6i. So 1/2 times 2 minus 6i squared plus 2 minus 6i minus 10. We're going to evaluate this with our binomial expansion. Keep our 1/2. Use our binomial expansion to turn 2 minus 6i squared into negative 32 minus 24i. And we have our plus 2, our minus 6i, and our minus 10. We're going to distribute this 1/2 into this parentheses to give us negative 16 minus 12i plus 2 minus 6i minus 10. Real numbers, we have minus 16 plus 2, so that's minus 14, minus 10 gives us minus 24. We have minus 12i minus 6i gives us minus 18i as our final answer. Number 4. Let's see, blue. For f of x is equal to x squared minus 4x plus 5, evaluate for 2 minus I. So, parentheses, 2 minus I squared minus 4 times 2 minus I plus 5. Expand this with binomial expansion. Gives us 3 minus 4i. That minus 4 distributes such that we have minus 8 plus 4i. And we've got that plus 5. Real components, we have a 3 plus our 5, that gives us an 8. Positive 8 minus 8, that's 0. Negative 4i, positive 4i, they're going to combine to give us plus 0i. So 0 plus 0i, well, that's just going to be 0, a real number. And that happens. When we see something like this happen, usually that means that whatever value we're plugging in is a root. That is to say, we plugged in this value and our function became 0. This is where this function hits the 0 y value. It's our root. Last one. Evaluate for f of x such that x squared plus 2x for f of 2 minus I. So 2 minus I squared plus 2 times 2 minus I. We're going to use our binomial expansion to expand that first part, which gives us 3 minus 4i. We're going to distribute that plus 2 to get plus 4 and a minus 2i. Combine our like terms. We've got a real 3 plus a real 4 gives us a real positive 7. We've got an imaginary minus 4i, an imaginary minus 2i. It's going to give us a minus 6i as our final answer. See, folks, largely it's the same process that we would use if we were plugging in variables or terms or numbers. Same process, just so happens that sometimes we're going to end up with real numbers, and sometimes we'll end up with imaginary numbers. For the assignment today, please show as much work as you are able to, and I mean line by line. At minimum, you should have about 3 lines of work. Take care, and please ask if you have any questions.